What if everything you've been told about confidence is neurologically backwards? What if the secret to unshakable self-assurance isn't in your mind, but in the 86 billion neurons firing beneath your conscious awareness right now? The 6 neurobiological pillars of unshakable confidence. 1. Confidence is neurobiological, not psychological. True confidence is a state of nervous system regulation involving optimal vagal tone and effective communication between the prefrontal cortex and limbic system, not simply a mindset or personality trait. When we examine confidence through the lens of neuroscience, we discover that what we perceive as charisma or self-assurance is actually the external manifestation of specific neural circuits operating in harmony. The dorsolateral prefrontal cortex, responsible for executive decision-making, must maintain clear communication pathways with the anterior cingulate cortex, which processes emotional salience and conflict monitoring. When these regions coordinate effectively, you experience what researchers call cognitive emotional integration, the ability to access both rational analysis and emotional intelligence simultaneously. The vagus nerve serves as the central conductor of this neurobiological orchestra. This cranial nerve extending from your brainstem to your abdomen carries more sensory information to your brain than it receives from it. High vagal tone, indicating robust vagus nerve function, correlates directly with increased heart rate variability, improved emotional regulation, and enhanced social engagement capacity. Individuals with higher baseline vagal tone demonstrate measurable differences in their ability to remain calm under pressure, process complex social information, and recover quickly from stressful encounters. What's particularly fascinating is how this system operates below conscious awareness. Your brain's insula continuously monitors interoceptive signals, internal bodily sensations like heart rate, breathing patterns, and muscle tension. This information gets integrated with external environmental data to create what neuroscientists call your predictive model of reality. When your internal state signals safety and regulation, your brain predicts positive outcomes and allocates resources toward approach behaviors rather than defensive ones. The amygdala, often mischaracterized as simply the fear center, actually functions as a relevance detector, determining which stimuli deserve attention and emotional response. In neurobiologically confident individuals, the amygdala maintains appropriate sensitivity without becoming hypervigilant. This allows for accurate threat assessment while preserving access to creative problem-solving and social connection capabilities. Perhaps most importantly, these neural patterns are remarkably plastic. Neuroimaging studies show that targeted interventions, specific breathing techniques, movement practices, and exposure protocols can measurably alter brain structure and function within weeks. The myth that confidence is fixed or genetically predetermined crumbles when we understand that your nervous system continuously updates its operating parameters based on lived experience and deliberate practice. 2. Physiology determines psychology. Your breathing patterns, posture, and overall nervous system state directly influence your confidence levels. You cannot think your way into confidence if your body is in chronic stress activation. The relationship between your physical state and psychological experience operates through what researchers call the embodied cognition framework. Your body isn't merely a vessel carrying your brain, it's an integral component of your cognitive and emotional processing system. When your shoulders are rounded forward, your chest is compressed, and your breathing is shallow and rapid, you're sending powerful signals to your brainstem that activate defensive neurobiological programs, regardless of what your conscious mind might be telling you about feeling confident. Your breathing pattern serves as the most direct interface with your autonomic nervous system. Each breath you take communicates information about your current state to your brain's control centers. Shallow, rapid breathing activates the sympathetic nervous system's fight or flight response, triggering the release of stress hormones like cortisol and adrenaline. These chemicals alter your brain chemistry, making it nearly impossible to access the calm, clear thinking that confident behavior requires. Conversely, slow, deep breathing with longer exhales activates the parasympathetic nervous system, promoting the release of acetylcholine and GAB, neurotransmitters associated with relaxation and focused attention. Your posture creates what researchers term proprioceptive feedback loops that directly influence your neurochemistry. When you adopt an open, expansive posture, chest lifted, shoulders back, head held high, you increase testosterone production while simultaneously decreasing cortisol levels. This hormonal shift occurs within minutes and creates the physiological foundation for confident behavior. Your brain interprets these postural signals as indicators of dominance and safety, adjusting its threat assessment protocols accordingly. The fascia system, the connective tissue network throughout your body, stores emotional and traumatic experiences in ways that directly impact your postural patterns and breathing capacity. Chronic stress creates fascial restrictions that limit your ability to breathe fully and maintain open postures. This creates a feedback loop where psychological stress manifests as physical restriction, which then reinforces the psychological stress pattern. Breaking this cycle requires direct intervention at the physical level. Temperature regulation also plays a crucial role in confidence states. Cold exposure protocols activate brown adipose tissue and increase norepinephrine production, creating a neurochemical state associated with resilience and stress tolerance. Heat exposure through sauna use promotes the release of growth hormone and heat shock proteins, supporting neuroplasticity and recovery. These physiological interventions create measurable changes in your capacity to remain regulated under pressure, the very definition of embodied confidence. 3. Action creates confidence, not vice versa. Confidence is built through taking action despite discomfort, which provides your nervous system with evidence of your capability and literally rewires your brain through neuroplasticity. The conventional wisdom that you need confidence before taking action fundamentally misunderstands how the brain learns and adapts. Your nervous system doesn't update its threat assessment protocols based on thoughts, affirmations, or visualizations. It responds to actual lived experience. Each time you engage in behavior that contradicts your brain's predictive models about danger or inadequacy, you create what neuroscientists call prediction error. This mismatch between expectation and reality triggers neuroplastic changes as your brain updates its algorithms to match new data. When you take action despite feeling uncertain or afraid, you're engaging the brain's error correction mechanisms at the deepest level. The anterior cingulate cortex detects the discrepancy between your predicted negative outcome and the actual result of your action. This detection triggers the release of norepinephrine and dopamine neurotransmitters that tag the experience as significant and worthy of remembering. Your brain literally rewires itself to accommodate this new information, creating what researchers term memory reconsolidation. The key insight is that your nervous system learns through pattern recognition across multiple experiences. A single positive outcome might be dismissed as luck or coincidence, but repeated successful navigation of challenging situations creates robust neural pathways. Your brain begins to recognize patterns. Discomfort doesn't equal danger, uncertainty doesn't equal inability, and taking action often produces better outcomes than avoiding action. These patterns become encoded as implicit memories, automatic responses that don't require conscious thought to activate. The phenomenon of stress inoculation demonstrates how controlled exposure to manageable challenges builds genuine resilience. Each time you voluntarily engage with discomfort and survive, you're literally training your stress response system to remain regulated under pressure. Your hypothalamic pituitary adrenal axis becomes more efficient, releasing stress hormones in appropriate amounts rather than flooding your system with panic responses. This physiological conditioning creates the embodied sense of capability that we recognize as confidence. The timing of action is crucial for neuroplastic change. Taking action while experiencing fear or uncertainty rather than waiting until you feel ready maximizes the learning potential of the experience. Your brain pays attention to experiences that occur during heightened emotional states, creating stronger memory consolidation and more robust behavioral changes. This is why confidence built through deliberate action in the face of discomfort proves more durable than confidence based on circumstances where you already felt comfortable or prepared. 4. Confidence is socially co-regulated. Your nervous system constantly co-regulates with others around you through neuroception, making your social environment crucial for maintaining regulated, confident states. The human nervous system evolved as fundamentally social, designed to function optimally within supportive group structures. Your brain contains specialized neural circuits called mirror neurons that automatically mimic and synchronize with the emotional and physiological states of people around you. This process occurs entirely below conscious awareness through what researcher Stephen Porges terms neuroception, your nervous system's automatic detection of safety or danger in social environments. When you're around someone whose nervous system is regulated and calm, your own system naturally entrains to their state through subtle cues including vocal tone, facial expressions, breathing patterns, and even pheromonal signals. This co-regulation process operates through multiple biological pathways simultaneously. Your vagus nerve picks up micro-expressions and vocal prosody that signal another person's internal state, automatically adjusting your own nervous system response. Heart rate variability studies show that people in close proximity literally synchronize their cardiac rhythms when engaged in positive social interaction. Even more remarkably, stress hormone levels fluctuate based on the regulatory states of people in your immediate environment. Spending time with chronically anxious or dysregulated individuals can elevate your cortisol levels within minutes. The polyvagal theory explains how your nervous system prioritizes different survival strategies based on social context. When neuroception detects safety through positive social cues, genuine eye contact, warm vocal tones, relaxed body language, your parasympathetic nervous system activates what Porges calls the social engagement system. This allows access to higher order thinking, creative problem solving, and the calm presence we associate with confidence. Conversely, when surrounded by people exhibiting defensive postures, rapid speech patterns, or emotional volatility, your own system shifts into mobilization or shutdown modes that make confident behavior nearly impossible. Social buffering research demonstrates how supportive relationships literally alter brain structure over time. People with strong social connections show increased prefrontal cortex density, better emotional regulation capacity, and more resilient stress response patterns. The reverse is equally true. Chronic exposure to critical, unpredictable, or emotionally unavailable people creates measurable changes in brain regions associated with threat detection and defensive responding. Your amygdala becomes hypervigilant. Your default mode network shifts toward rumination and self-criticism, and your capacity for the open, receptive state that confidence requires becomes severely compromised. Understanding this biological reality transforms how you approach relationship choices, making social environment curation not just a lifestyle preference, but a neurobiological necessity for sustained confidence development. 5. Mastery mindset enables distress tolerance. True confidence involves developing the ability to remain engaged and regulated during failure and uncertainty, viewing challenges as neuroplastic opportunities rather than threats. The distinction between a fixed mindset and growth mindset isn't merely philosophical, it creates measurably different patterns of brain activation when encountering challenges or setbacks. Individuals with mastery orientation show increased activity in the anterior cingulate cortex and prefrontal regions when facing difficulties, indicating maintained access to executive function and problem-solving capabilities. Those with fixed mindsets demonstrate heightened amygdala activation and decreased prefrontal activity, essentially hijacking higher-order thinking in favor of defensive responses. This neurological difference explains why some people become energized by challenges, while others become paralyzed by them. Distress tolerance, the capacity to remain psychologically present during uncomfortable emotional states, represents perhaps the most crucial skill for sustainable confidence. Your brain's prediction system constantly generates expectations about future outcomes based on past experiences. When you encounter failure or uncertainty, this system often generates catastrophic predictions designed to motivate avoidance behaviors. However, individuals with high distress tolerance have trained their nervous systems to distinguish between discomfort and actual danger, allowing them to remain engaged with challenging situations long enough to gather new data and develop more effective strategies. The neuroplasticity research reveals that your brain remains remarkably adaptable throughout your entire lifespan, but this plasticity is most pronounced during states of focused attention combined with moderate stress, exactly the conditions created by voluntary engagement with challenging situations. When you approach difficulties with curiosity rather than defensiveness, you activate what researchers call metaplasticity, your brain's ability to strengthen its own capacity for change. This creates an upward spiral where each challenge successfully navigated increases your tolerance for future challenges. Failure reframing represents a sophisticated cognitive emotional skill that directly impacts nervous system regulation. Instead of interpreting setbacks as evidence of personal inadequacy, mastery-oriented individuals process them as information about strategy effectiveness. This reframe activates different neural pathways, specifically increased activity in the dorsolateral prefrontal cortex associated with cognitive flexibility and decreased activity in regions linked to self-referential rumination. The result is faster recovery from setbacks and more effective problem-solving in subsequent attempts. The concept of confident uncertainty emerges from this neurobiological foundation. Rather than requiring certainty about outcomes before taking action, mastery-oriented confidence involves trusting in your capacity to learn, adapt, and respond effectively regardless of what unfolds. This represents a fundamental shift from outcome-based confidence to process-based confidence, trusting not in your ability to control results, but in your ability to navigate whatever results emerge. 6. Specific protocols build systematic confidence. Evidence-based practices like physiological sighing, microdosing discomfort, embodied posture work, and intentional social curation can systematically develop authentic confidence over time. The physiological sigh protocol represents one of the most powerful tools for real-time nervous system regulation. This technique involves 2 inhales through the nose, followed by a long exhale through the mouth, directly targeting the brainstem circuits that control autonomic function. The double inhale maximally inflates the alveoli in your lungs, activating stretch receptors that send calming signals to your vagus nerve. The extended exhale then shifts your heart rate variability toward parasympathetic dominance, creating the physiological foundation for confident states within 30 seconds. Neuroimaging studies show that regular practice of this protocol literally enlarges the prefrontal cortex regions responsible for emotional regulation while reducing amygdala reactivity. Microdosing discomfort operates on the principle of hormesis, the biological phenomenon where small doses of stress create adaptive responses that build resilience. By deliberately engaging in mildly uncomfortable situations daily, making eye contact with strangers, speaking up in meetings, trying new activities, you're systematically training your nervous system's stress response mechanisms. Each exposure creates what researchers call stress inoculation, gradually raising your threshold for activation while maintaining access to higher-order thinking under pressure. The key is calibrating the discomfort to remain within your window of tolerance, challenging your system without overwhelming it. Embodied posture work leverages the bidirectional communication between your body and brain through proprioceptive feedback loops. Specific postures, particularly those that open the chest, lift the sternum, and create spinal extension, trigger measurable increases in testosterone and decreases in cortisol within 2 minutes. These hormonal shifts create the neurochemical substrate for confident behavior while simultaneously sending signals to your brain that you're in a position of strength and safety. The practice becomes even more powerful when combined with specific eye movement patterns that activate the sympathetic nervous system in controlled doses. Intentional social curation recognizes that your nervous system is constantly co-regulating with those around you through unconscious neurobiological processes, creating what researchers term social scaffolding, surrounding yourself with people whose nervous systems are regulated and who genuinely support your growth provides the interpersonal neurobiology necessary for sustained confidence development. This involves not just adding supportive relationships, but actively minimizing exposure to chronically dysregulated individuals whose stress states can hijack your own nervous system through emotional contagion. The practice extends to digital environments, as social media consumption patterns directly influence neurotransmitter production and nervous system regulation. Strategic implementation of these protocols creates compounding neuroplastic changes that transform confidence from an occasional state into a stable trait. Your transformation begins with your next breath. For the next 7 days, I challenge you to implement just one protocol from what we've discussed today. Choose the physiological sigh technique, 2 inhales through your nose, long exhale through your mouth, and practice it for 5 minutes each morning. Notice how your nervous system responds. Feel the shift in your internal state. Document the changes in how you show up in challenging situations. But don't stop there. Your confidence is too important to leave to chance. Hit that subscribe button and turn on notifications, because next week we're diving deep into the neuroscience of social confidence, how to read the room, influence group dynamics, and become magnetic in any social situation using cutting-edge research on mirror neurons and social brain networks. Share this video with someone who needs to hear this message. Comment below with your biggest takeaway from today's discussion. And remember, confidence isn't something you have or don't have. It's something you systematically build, one neuroplastic experience at a time. Your nervous system is waiting for you to give it the evidence it needs. The question is, are you ready to provide it?